Hello students, in this video we'll see how to compute the variance of a random variable whose PDF comes from the linear exponential family. Let's suppose that y has distribution in the linear exponential family. Then, if this is the case, then we can write down its PDF. So the PDF of y will be the exponential of y times the parameter theta minus a function of that parameter over phi plus some function of y and phi. And we saw previously that the expected value of this random variable was equal to b prime of theta. So what we'll do, and we saw this by looking at the integral over r of the exponential of y times theta minus b of theta over phi plus a of y phi dy. We know that this integrates to 1 since it's a PDF. And so what we did is we took the theta derivative of this equation. And what we saw is we saw that b prime of theta was equal to the integral over r of y times e to the y theta minus b theta over phi plus a of y phi dy. In the formula we actually drove was that it was the integral over r of y minus b prime of theta over phi times the exponential of y theta minus b theta over phi plus a of y phi dy was equal to 0. And so what I'd like to do is I'd like to differentiate this equation again. So let's do we'll do the second derivative, or the derivative of the derivative. Again, the left-hand side will be equal to 0. And then we'll have to do the derivative of this first term over here with respect to theta. And then the derivative of the second term. So what we'll get is the following. The first term we'll get a 0 is equal to the integral over r of the derivative of the first term will be negative b double prime of theta over phi times the exponential of the standard factor. So this whole thing over here, we'll just put that in the box. That will be what our box is. And then we'll have a dy. And then the second term we'll get is we'll get this term over here squared. So we'll get that term squared plus the integral over r of y minus b prime of theta over phi quantity squared e to the box term dy. And we'll notice that what we have is we can therefore equate the integral over r of b double prime of theta e to this box dy to be the integral. There's one phi over here and two phi's over here, so what I'll do is I'll put an extra phi over here, and that will, by multiplying phi squared to both sides of the equation, is equal to the integral over r of y minus b prime of theta quantity squared e to that box dy. Now notice over here that phi and b prime are constants, so this left-hand side is exactly equal to phi b double prime of theta. And now what we have over here is we recall that b prime of theta is the expected value of e of y. So this is the expected value of e of y. And so what this expression over here is equal to is it's the expected value of y minus the expected value of y quantity squared. And that quantity over there is exactly equal to the variance of y. That's the variance of y. And so we can conclude from this that the variance of a random variable, y, that's in the linear exponential family, is equal to the parameter phi times the second derivative of this function b with respect to theta. Thank you very much.